Hello, welcome back to another video. In this video, we'll discuss about some observations from the 2's complement table. Okay, and here the 2's complement table is based on the 4-bit representation. Here the number of words is 4 or n is 4, or sometime in some books you will be able to see they represent the bit with the p. So we can say that 4-bit is nothing but n equal to 4 or p equals to 4. Here in the first column you can see there is a decimal representation, the second column binary unsigned representation, and then 2's complement representation in the 4-bit, and I have given a note over here. And as you can see here, we'll you can see that it is starting from 0, then it is having the positive number, and below here the negative number in the decimal column. And if you represent the binary unsigned bit, then it will be look like this. And you know that in case of unsigned we don't have any positive number, negative number, so that's why you have given the na. And if you represent it in a 2's complement, so it will be look like this one, and for the rest of the negative number it will be look like this one. So as you can see here, you have to remember that maximum positive number in the 2's complement, it will be 0 1 1 1. Minimum number or the mean negative value here 1 0 0 0. And you know that for the negative number, if you want to represent in the negative number, then what you have to do, you just have to invert the number. Invert the number, and then invert the number means you have to convert it to it in the binary equivalent. It will be 0000, sorry, 0001, and then you have to invert it, it will be 1110, then you have to plus 1. So this is the basic rule how to convert into 2's complement. I already have discussed and given some example, you already know that. So in this way, this number actually coming in the 2's complement form, which is actually negative number. Here you have to look at the all the for the all negative number in the 2's complement. You can see that 1 is here, so this is the most significant bit. So most significant bit is here 1, and for the positive number, all you can see this is the 0. So for all positive number it will be represented as a 0, and the most significant is 0. And here only 1 0 is present in this table, correct? So representation of 0 in positive and negative both are 0 in 2's complement form. So here you have to note down one thing, that the most significant bit or sign bit, 0 means positive number and 1 means negative number. So in the 2's complement form, if one number is starting with a 0, that means that is the positive number, and if one number is starting from 1, then it means that that number is a negative number. As I have shown that -8 is the most lowest value that can be represented in the 4-bit, and +7, so this number +7 0 1 1 1, this one is the highest value in the 4-bit. Okay, now one observation that you have to remember, that in the 2's complement there is a one unique 0. So as you can see, 0 means 0 0 0 0 0 0 0 0 in 4-bit representation. In 2's complement representation, 0 has the single unique binary representation, all bits are 0. So if it will be 8-bit, then it will contain the 8 consecutive zeros. In our case, we are using 4-bit, that's why it will be 40, that means the 0. So if we'll take the 2's complement of the 0, it will be 0 as well, because it will be all 1, then we have to add +1, so everything will be 0, and the most significant bit will be 1. But in 4-bit representation, that 1 will be discarded. So I'll show you that as well. Okay, so here as you can see that the 2's complement of 0, the 2's complement of 0 is 0. How it is Now let's look at 2's complement of a number is formed by inverting all bits. That means we have to do 1's complement, then I have to add 1, correct? So for 0, first if I'll invert it, everything will be 1, and if I'll add 1, then it will be 0 0 0 0 1. If I'll truncate it to the 4 bit, then it will be remain 4 zeros. So 1's complement plus 1 will be 0 0. Okay, so this is a 4 bit, so that's why we can say 2's complement of 0 is 0. So this is the one observation that you have to remember. Now next thing, the leftmost bit in the sign bit. Leftmost bit is the sign bit. So I already have discussed this one. So leftmost bit is the MSB or most significant bit. 0 means positive number and 1 means negative number. The most significant bit does not carry quantity, but merely it indicates the sign. So this one is not carrying the quantity of the number. It indicates the sign. In case of negative number also, this last one, the most significant bit or the leftmost bit, is nothing but the sign bit that you have to remember. This is the one of the observation that always you have to note down. Okay, now let's go to the next point, that is the distribution of number. How many numbers will be there or how many state will be there? So if we'll count here, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, total 16 number is there. So if I'll represent the 4 bit with the p, then the for any p bits to us complement system, total unique number is 2 to the power p, means 2 to the power 4, that will be 16. So that is why we have total 16 rows over here, and total unique, that is also a total unique number, that is from 0 to plus 7 and minus 1 to minus 8. And total negative numbers will be 2 to the power p minus 1, that is 2 to the power 4 minus 1, that will be 3. 2 to the power 3 equals to 8. So that is the total number. So as you can see, so from here you can see minus 1 to minus 8, these are the negative numbers, total 8 negative numbers. So that is why 2 to the power 4 minus 1, that is 2 to the power 3 equals to 8. If I'll talk about the positive number, then 2 to the power 3 minus 1, that will be your 7, right? So 2 to the power 4 minus 1, that is 2 to the power 3, means 8 minus 1 equals to 7. So that is why you can see from positive 1 to positive 7, these are nothing but total 7 positive numbers are there, and 1 0 will be there. So total number will be here, the 7 plus 1 plus 8 equals to 16. So here I have given the example as well. Total number 2 to the power 4, that is the 16, negative number 8 from minus 1 to minus 8, and positive number 7 from plus 1 to plus 7 and 1 0. So total numbers will be 8 negative numbers, 7 positive number and 1 0. That is the 16 unique state will be there, or 16 unique values will be there in the 2's complement number system, 2's complement system for the 4-bit representation. Okay, so this is the distribution of values. Now let's talk about the another observation for the 4-bit representation. So ones and zeros carry significance here. So first let's talk about the positive number. Positive numbers have the most ones, especially on the right side. If you'll see these numbers, positive numbers, you will be able to see in the right side there will be more 1 will be there. So if we'll take the plus 3, as you can see, it is having the double 1 in the last right side, as well as if you will take the 7, you can see that you are getting ones in the right side. So positive number have more ones, especially on the right side. In case of now, if we'll look at the negative numbers in the 2's complement system, then you can see that typically it starts from 1, so all negative starts from 1 and have the 0 towards the end. And if you'll see towards the end, you will get more number of zeros. If you look at the -3, you will see like this way, 1101. If you will see -7, so you can see -7. First one is the 1, and then you can 001 like this way. So just pause the video and try to understand this point. If you will not think about it, you will not get this observation. So why it is happening? Because for the positive numbers, for all these positive numbers, bit increases as you add more ones to it, and for the negative numbers, bit decreases as you increase trailing zeros, because it's like the subtracting, right? uh, if you compare it, like a positive 2 and the negative 2, so you can see in the right side, if you increase the number in the right side slowly, it will get more number of ones, right? And if you go to the negative number, if for the 16-bit representation, as you can see in the left side, we are having the number of ones and then zeros. So if you increase the negative number, right, then in the right side you will get more number of zeros. For the positive numbers, you will get more number of ones in the right side. So that is the one of the observation for the 2's complement. So notice how ones are significantly positive in the number, ones are significant in the positive number, and zeros are significant in negative due to the way it stores. So this is the one of the observation. Just you can pause and you can think about it. Okay, now let's talk about our next observation, that is the conversion between the negative and the positive. So if you want to convert from negative to positive number, then you have to take the 2's complement, that is the you have to invert it, or 1's complement, and then you have to add a +1 with it. In case of positive number to negative number, this is the same way. You can see the example over here. For example, if you want to convert +5 to -5, then how we can do that? I have to invert it, this number. I have given the example in other videos. You can see that for step by step. But if I'll invert it, it will be look like this. All zeros will be 1 and ones will be 0. So this is the inversion, and then if we'll add it, then it will look like this, and this will be the -5. Okay, and if we'll reverse it, then it will go from -5 to +5. So I hope now it's clear. We have discussed a total 5 observation and discussed about the 2's complement table. If you have any question regarding this presentation, you can write it in the comment section. I'll try to solve your problem as soon as possible. So thank you for watching this video. See you in the next one. Till then, take care. Bye bye.